Hi, today I want to spend a little bit of time talking about databases, and in particular database schemas and how we manage those in a Kubernetes native environment. Before we get started, I want to introduce myself. My name is Marc Campbell. I'm the CTO and co-founder of a company called Replicated. And the goal of this talk is to really present the idea of declarative schema management as a Kubernetes operator, and in particular, the implementation that we've open sourced in a project we've been working on at Replicated called SchemaHero. To help explain how I'm thinking about this problem, I want to present a story of two different developers. The first developer is a Django developer, and she's writing and deploying an app to Heroku. The second developer is a Java developer, writing and deploying an app to a Kubernetes cluster. I want to walk through a couple of scenarios for the day-to-day of these developers. The first scenario, both of these developers are adding a new feature that requires a database schema change. Our Django developer, she's just going to edit her Python file, add a new class, save it, and push it to Heroku. What happens when she does that is Django is going to automatically deploy the database migration, wait for that to complete, and then start the new version of the application. Our Java developer edits the source file of the Java class, but he also needs to make that database schema change separately. He's using Liquibase to manage those schema migrations. So he goes ahead and creates a new migration. This one's number 913 because it's a relatively mature project. He looks up, remembers how to write the SQL statements for the DDL for how to modify the schema, references Stack Overflow probably, and ends up creating this alter table statement, which adds a new column with a default and a foreign key that references the other table. That's great. So he's using GitOps because everything's automated. He commits that into source control, has a code review, and once it's merged, lets Flux automatically deploy a custom Kubernetes job, and that runs, performs the database migration. He monitors that, and once it's completed, then he merges his code change and let that deploy in order to use the new schema. So what's the difference between these two scenarios? The Django developer, she doesn't need to know that DDL statement to create the foreign key. She just adds it in using her ORM. And our Java developer, had to know the SQL statement in order to create that foreign key. Another difference is that our Django developer just deploys everything in a single atomic unit as one commit. And our Java developer deploying to Kubernetes using Liquibase in a custom job has a brittle multi-phased orchestrated deployment. He has to deploy that schema, monitor it, and then deploy his application his application change separately. Another scenario I want to walk through is both of these projects, they want to create a new environment. They want to deploy their application into a new cluster. Our Django developer creates the database tables. She just deploys it, lets Django create all the tables, and it's done. Our Java developer has 913 migrations to run against this new empty Postgres server, but it's okay, it's all automated. He just creates it, deploys it, Flux runs through 913 migrations, and the end result is going to be the same, right? Sort of. In this scenario, though, an older migration, number 474, so a few months ago, depends on a Postgres module that was implemented for a search feature that was later removed and rewritten, re-architected, so we didn't need that in the end. But the migrations fail. They fail at migration 474 for him because he needs that module in order to allow it to install it, even though it's going to uninstall it 100 migrations later. There's a couple options he could do. He could rebase these migrations. He could delete that change, cherry pick through it. But this is a common problem that you run into. The differences between the two here are our Django developer just deploys the desired state of the database. She knows, here's our code, here's the class, lets the ORM automatically deploy what's needed. And our Java developer, he actually deploys the history. So he walks through everything that converges to that desired state. And another difference because of this is that our Django developer doesn't need all of the old dependencies that we ever needed. And our Java developer needs everything that's ever been required. So if a migration required a certain encoding or a module or expected a specific version of the database engine, it's going to be needed in order to successfully complete unless we go back and rewrite that migration later. Final scenario I want to walk through is auditing the schema. So a question's raised, is there an index on this column? And so both of the developers want to understand that to answer that question. And of course, we want to do this in a way without direct access to that database. So our Django developer just looks at the Python class, looks to see if there's an index defined in the attributes on the class. Great. In our Java developer, everything is in code also, so he just opens up his editor, looks at the migration files. It does have to, Command Shift F or whatever and search through 913 migration files for the table name, reads them to see if that index has ever been created or dropped, in like what order it is, and that way he can reconstruct the final state of that table to answer the question. The differences between here are that she just has a single place that has the desired state, and he doesn't. Again, he has all of the instructions that he can use in his head to converge on what that desired state is. So this raises the question, what if there was an ORM specifically designed for database schemas? Some platforms have this today, right? So Django, as we just talked about, has a built-in ORM that manages database schemas. Flask apps for Python, you can use SQL Alchemy and other tools. Java and Spring have Hibernate. You can use that for schema management as an ORM. And Node has a few projects. They're a little bit fragmented in that ecosystem. Most platforms do have some platform-specific functionality to manage schema ORMs. Not all, but they do. Java being a popular language, a question was asked on Stack Overflow a while ago. Should I use Hibernate to automatically manage schema in production? And the highest answer back from 2016 said no, it's unsafe. And the explanation is pretty detailed. And the interesting part I highlighted in red here says you actually do want the DDL to be generated automatically, but you absolutely want that change to be inspected by a human before you run it in production. So I want to present a project we've been working on called SchemaHero. SchemaHero is a language-neutral, declarative state, GitOps-friendly Kubernetes operator database schema ORM. So that's a lot. That's a mouthful. We're going to drill into it, do a demo, and kind of explain it. So specifically, what we're built is a Kubernetes operator to manage database schemas in a language-neutral state or system. So it doesn't matter whether you're running Python or Rails or Node or Go or Rust or Java or any other language and any other tooling. It does SchemaHero is a tool specifically meant to manage the database schema, and it does it through a declarative state in a way that's GitOps friendly. How does SchemaHero work? It's pretty simple. It's a Kubernetes operator. The first step is that you want to deploy a kind database. So this is a Kubernetes custom resource. SchemaHero operator implements the reconcile loop for it. This kind database, you give it a name and you deploy it to a namespace. But the key part here is that this just contains the connection information for the database and a name. So in this example that's on the screen right now, this is a Postgres database, and the custom resource is saying the connection URL, the connection URI to connect to this Postgres database is in a secret named PostgreSQL and a key named URI. You can put credentials in here using secrets. You can put them right in here. You can use HashiCorp Vault or AWS parameter store. There's various methods that you can use, but the database object just is a pointer to how to connect to the database, whether that database is in the cluster or out of the cluster. Next, you want to deploy a kind table. Chances are you probably want to deploy more than one of these because most databases have multiple tables. It looks something like this. So this kind table references the database object that we just deployed, and it defines what the desired schema of this table is. On the example that's on the screen here, we have a couple of columns, code and name. So this defines what the columns are, what the types of these columns are, any constraints on the columns. And in addition, you can define primary key, indexes, unique indexes, foreign keys, any other schema that you need on this table. Once you've deployed this kind table, the next step is just to view and approve the migration. So using the SchemaHero CLI, which is distributed as a kubectl plugin, you can just view the migrations and then describe a migration. So here we've deployed a migration, and when I run kubectl SchemaHero describe migration, you can see that the output shows the generated DDL statement. And that's a create table command. And then it gives you a couple of commands down towards the bottom to be able to approve that migration, reject the migration, or recalculate the migration. Approving the migration will actually just run that DDL statement that's presented on the screen that SchemaHero calculated. Rejecting the migration will mark it as rejected, not run it, and prevent it from being executed. And recalculating the migration tells SchemaHero to go take the desired state and compare it to the actual database schema that's running and regenerate the correct create table statement. That may be useful if the underlying database schema has changed, somebody manually altered it, or another tool has edited the schema. So SchemaHero will then regenerate the DDL statements that are necessary. So to help demonstrate this, I want to show a little bit of a demo on how SchemaHero works. So here I have a Kubernetes cluster set up. It's an EKS cluster, doesn't really matter. This is Kubernetes 1.16, and I also have an RDS instance set up. And the RDS instance is set up on the same VPC, but it's only connected into my private network. So we look here, and this is, like I mentioned, it's a Kubernetes 1.16 cluster running 5 nodes. I'm going to now deploy SchemaHero and deploy a database to it. So to start with, I want to deploy a secret, and the secret contains a connection string. And this connection string is base64 encoded, but it's to this test database instance that we have on RDS. So if I apply that, it may already be applied. That secret is there. That's great. And so the next step I want to do is deploy the SchemaHero operator. So I have kubectl SchemaHero already installed. This is distributed as a crew plugin, so you can do kubectl crew with a K, install SchemaHero, and that'll give you the client-side components to manage a SchemaHero operator running in your production environment or any environment. So I have SchemaHero 0.10.1 installed here, so I can run kubectl SchemaHero install, and that installs the operator, the CRDs, and the manager into the cluster. Now that that's installed, we can take a look back here. I have a airline DB file. So I want to, the scenario that I want to present here is deploying a small database that is, could be used to manage airports and airline reservations. So this CRD, this custom resource is the database kind for SchemaHero, and it references that secret that I just deployed. So we're going to go ahead and deploy that now. If we apply that, now we have that database object deployed, and that hasn't done anything yet except just point SchemaHero, allow SchemaHero to start managing this database. The next step is I want to deploy a single table. So this table is named airport, and we reference it that it's in the airline DB database. And you can see here I'm identifying declaring 2 columns that I want, the code and the name, so the airport code and the name of the airport. And I'm saying that the primary key is the code key, or the code column. And that's an array. It can be multiple columns if you have a composite primary key, but in this example, this is a single column primary key. So we're going to go ahead now and apply that. And now that that's applied, I can run kubectl SchemaHero get migrations. When I run this, I can see that the airport table in the airline DB was planned 6 seconds ago. And so planned means that the SchemaHero controller took that table YAML and compared it to what's actually running in my RDS instance and generated all the necessary SQL statements, the DDL statements that are needed in order to migrate the RDS instance to the state that I have in my YAML. We can actually take a look at this migration if we just describe that migration. And when I do this, you can see that the migration name is what I just provided, and the generated DDL statement here is what SchemaHero has calculated that it's needed to turn that RDS instance into the desired state. And it didn't find that airport table because this is a new database, and so it just generated a create table statement. Gives me a couple options. I can approve this, I can reject it, or I can recalculate it if I need to. I'm going to go ahead and just approve it. And now that I've approved it, when I get migrations again, you can see that it was planned a minute ago, I approved it 4 seconds ago, and SchemaHero executed it 4 seconds ago. So I'm going to head over here to my UI that I use to look at my Postgres cluster, Postgres database, and I'm going to refresh the tables that I have. And you can see now I have an airport table. I didn't have that before, and it has these 2 columns, code and name, which meet the requirements in what I wrote in that YAML. Now I want to show what it's like to edit this. And so let's say I want to add a new column into here, and I want that column to be named, I don't know, postal code. And that's going to be a type text. And let's add a constraint onto this column, and that is not null true. So we're going to add a new column, postal code type text, not null. And while we're at it, let's say that we don't want any duplicate names inside our airport table. So I'm going to come into here and add an index. And the index is going to be on the name column. And again, it's an array because I can have composite indexes that span multiple columns. In this case, I'm not doing that. I want that to be a unique index. And I could name the index if I want to, but I don't really have a strong preference about the name. So I'm going to let SchemaHero go ahead and calculate that. And now when I apply that migration again, or that YAML again, I have an error because the key is actually named indexes. So when I apply that YAML again, it runs that. And now when I look at, let me come back here and get migrations, you can see there's a second migration for the same table that was planned 6 seconds ago. And if we run kubectl SchemaHero, describe that migration, you can see that it's generated a couple of new DDL statements. It wants to alter the airport table, adding the postal code column text not null, and then it wants to create a unique index named this on airport with that name column. And it gives me commands again to approve or reject it. I'm going to go ahead and just approve that for this demo. So I approve it. And if I run get migrations again, you can see that, again, it was approved 4 seconds ago, executed 3 seconds ago. And when we come back here into our UI and we refresh the tables that we have, our airport table now has a postal code column and it has a unique index on name. It's like the state that I just deployed is there. Great. So SchemaHero has a few options that we just talked through. You can get tables. And this shows you can view all of the tables that you have, and you can view what the expected and the desired state of these tables are. You can get migrations. You can filter them by database in case you're managing multiple databases. And this shows you all of the different migrations that you've run, describing a migration. You can see here, an example of a little bit more of a complex one that we have, where it's this one table has multiple alter table statements that it wants to run because that was all deployed in one iteration, one version of that table resource. Next, I want to talk for a minute about migrating to or converting to SchemaHero. So chances are you already have a database running in production, or that you're thinking this might be useful for. And you don't have to. This isn't only good for like new databases. We put some effort into how do we migrate an existing schema into SchemaHero. So this kubectl SchemaHero generate command takes a URI to that database. If you pass that URI in, the kubectl SchemaHero plugin is going to connect in, view the schema of all of those different tables, and write a YAML file for each of those tables. So this is a really easy way to export your schema from a running database into all of the YAML files that are necessary, and then you could edit one of these YAML files and apply it, and now you're managing that schema through a declarative state of SchemaHero. Taking a step back and reviewing, what does SchemaHero do? What does it enable that's unique versus other ways, imperative ways, or writing SQL statements for database migration? First, it gives you a really easy way to do GitOps for database schemas. Whether you're using Argo or Flux or Argo Flux or any other GitOps tool to handle deployment, you could probably build this yourself today by running custom Kubernetes jobs, deploying these that run the DDL statements. We talked about that a little earlier. But SchemaHero has this all built in. You can now just run kubectl apply or let one of these tools deploy the YAML, and then you have a full GitOps pipeline in order to manage your database schemas. It enables policy enforcement for database schemas using tools like Open Policy Agent, Gatekeeper, or ConfTest, or anything like this. Now that we have our database schemas defined as a declarative structured YAML file instead of imperative statements, we can run policy against those. Apply policies allows us to do unique things like have requirements and enforce requirements around primary key existence on tables, foreign keys, names, types of different columns, anything that you want to be able to do that you can define in a Rego file, you can now enforce against your database schema. You can have easy approval process. The demo I just showed and everything we've talked through is kind of walk through that two-step process where I deploy the YAML file, allow SchemaHero to plan the SQL statement, and then I decide to approve or reject it. That's really useful if you want to monitor to see what's running. But if you have other environments, dev test environments, or different environments where you don't need that level of control, you can actually have SchemaHero automatically approve the migrations as soon as it calculates them. So that gives you a full end-to-end automated schema management that does not require anybody to look at the DDL statements. Really useful if you pair that with policy at code time, so that you're validating that only certain policies or only certain migrations could be generated. This removes the need to write DDL specifically. Like, it's not a replacement for SQL. Your developers still have to write SQL or use an ORM at the application layer, but the syntax around creating foreign keys or complex alter table statements, there's lots of different ways that you could do this that could lock a table or not lock an entire table depending on how you write these migrations. SchemaHero codifies all this up with best practices, so it's able to generate like the most optimal DDL statements possible, or that it is able to do. It eliminates the need to write these custom jobs, right? And this is an example from a cluster that I've seen where it's actually using Goose in this case to run database migrations, if you're familiar with that tool. And every database migration runs as a job, and then they sit there forever. Hopefully you're cleaning them up better than this, but it's not uncommon to be using Kubernetes jobs in order to manage database schemas right now, and this eliminates that need. SchemaHero currently supports some popular commercial and open source databases from Postgres, CockroachDB, and MySQL. Cockroach is very similar to Postgres, but it is a little bit different, and the schema management can be a little bit different at times. So SchemaHero creates some new options that we didn't have before, one of them being to detect drift in our databases. So now that we have the desired state of our databases deployed into the Kubernetes cluster, if something out of band has modified the schema, SchemaHero will generate a migration to bring it back into where we want it to be. It'll remove that drift. So it's really useful to determine that, to use this as a tool to automatically see if your database is not what you expect it to be, if the schema changes in any unexpected ways. You can also enforce and audit schemas using tools external, other CNCF projects like Gatekeeper, ConfTest, and other tools. For things like I mentioned before, column names, any kind of policy or best practices that you want to implement. You can do this. You can do it in a GitOps or in a commit check now or in code review. You can easily test schema on updated versions of database engines. So as an example here, if you were running MySQL 5.6 and now you're looking to upgrade to MySQL 8, but there was some functionality that was deprecated along the way and removed in 8.0, your migrations are no longer going to work, because if you run them on a new MySQL 8 database, it's going to fail because the statement is no longer compatible with the DDL that MySQL 8 supports. So think of this as like auto rebasing these. You could manually go back through every time you want to change database engines and recalculate all your migrations for the new version. SchemaHero just does this automatically by nature of what it does. And it's really easy to test the schema on a cloud native version of the database engine. So if you're looking at migrating from, say, Postgres to CockroachDB, but there's some slight differences in the DDL statements and support between the two engines, SchemaHero is a good use for this because you can take that schema, run it against CockroachDB. SchemaHero understands how to calculate the migration commands in the create table and alter tables on CockroachDB versus Postgres when there are little differences between the two or unsupported changes. And so it's really easy to not think about that abstraction, like let SchemaHero be that abstraction, so you don't have to understand those differences of implementing the schema on each of them. SchemaHero doesn't do everything though. It doesn't do database migration or data migrations right now. In particular, if you have business logic you need to run around, creating, modifying data, splitting columns, doing something that actually involves writing code, you're still today better using something like Goose or Flyaway or, another migration tool that can handle that data migration, at least for that layer. We're super open to having this as part of SchemaHero. It's not there today. There's a GitHub issue where we're discussing the plan and the design for how we could do this. Love to have some help there. And it's not SchemaHero is not an application runtime ORM. So if you are using an ORM so that developers don't have to write select statements and update and delete statements at runtime, that's great. That's super compatible with everything SchemaHero is doing. SchemaHero wants to really focus on becoming the schema ORM. So next, we have some changes we want to add in. We want to continue development of SchemaHero. We're looking to add in additional database engine support. So Yugabyte, Spanner, TidyB, Vitesse, anything like this. Basically, any relational database. We think that there's a schema for it, and SchemaHero would be a great tool to manage that. We do plan to submit SchemaHero to the CNCF as a sandbox project really soon. Like I mentioned before, we're talking about adding data and server migration capabilities into SchemaHero so that it can do more than just schema. It can handle all migration, all deploy time migration type tasks. And we're looking for contributors and users really into the project. So if it's interesting, we'd love to have you try it out and give some feedback and see, where it fits use cases and what changes we need to add into the project to make it fit even more use cases. That's it. Thanks, everyone.